Hey everybody, welcome back. Today's video we're going to start lesson 3.5. It's a very important one. It is about slope and slope-intercept form. But today we're just going to worry about slope. I was assuming that maybe you have done this in 7th grade because this is sometimes something you talk about if you're in the advanced class in 7th grade, but I can't guarantee it, and without you guys here in person, I'm not sure. So I'm going to go ahead and go over this like you've never heard of it, and if you have heard of it, I apologize. It may be something that's kind of a little boring. So anyway, in this lesson, we're going to talk about slope of a line. And this is straight out from our book. These definitions, I'll just read it. The slope is the rate of change between any 2 points on a line. Just any 2 points. Doesn't matter which points you pick. They should always have the same slope between any 2 points on a line. It's the rate of change. Another way to phrase it is it's a measurement of the steepness. How steep is the line? The bigger the number, the more steep that the line is. The smaller the number, the less steep that the line is. There are a couple different ways that you'll see people represent slope. The old school way that I learned back in the olden days before cell phones and internet, back in the 1990s, was rise over run. Your textbooks will say it's the change in the y compared to the change in the x as a fraction, and then you always reduce that fraction. The actual formula is right over here. Slope is y2 minus y1 over x2 minus x1. And notice these are not exponents. They are called subscripts because they're down below, and the 1 and the 2 just mean point number 1 and point number 2. Like if I said, hey, what's the slope between these 2 points? I'm just going to make up some numbers here. You have the choice. Like you get to pick one of them to call point number 1. Like maybe I say, okay, this is going to be my number 1. This is going to be my number 2. It doesn't really matter which one you call number 1 and which one you call number 2. And then remember, you always have the x coordinate and the y coordinate in alphabetical order. And then you have the x coordinate and the y coordinate in alphabetical order here. So like y2 is really the y coordinate from point number 2, right? Point number 2, the y coordinate. These are both 2's because they came from point number 2. Here's my point number 1, and we can call this one x1 and y1. So that 1 and the 2 just signifies it either came from the first coordinate or the second coordinates. It doesn't really have anything to do with exponents. And so then you can just plug them in there. In my example, I would be doing y2 minus y1. y2 is the y coordinate from point number 2. That's 9. Minus the y coordinate from point number 1. So point number 1, my y coordinate right here is 5. So I'd have 9 minus 5, which obviously equals 4 on top of my fraction. And then we would do the same thing with the x coordinates on the bottom. The x coordinate down here, x2 minus x1. Point number 2, my x coordinate. Point number 2, my x coordinate is 5. Whoa. Sorry about that. And then x1 means the x coordinate from point number 1. Here's my point number 1. The x coordinate is 3. And so 5 minus 3 equals 2. And then obviously we could reduce that. 4 over 2 equals 2. Now, could you say 2 over 1? Yes. But most people will just put 2. Now notice what I put there. The abbreviation for slope is the lowercase letter m. Why in the world did they pick the letter m to represent slope? I don't know. Every year I say I'm going to look that up and try to figure it out, and I haven't ever done it. So for some reason, m is always the abbreviation for slope, if you ever see that. But it's always the change in the y, the vertical change, the rise, compared to the run. So today we're going to learn how do you do it when they give you points, like I just did right here, and we'll also learn how do you do it whenever they give you a graph. So how do they look like as graphs? Just as a quick reference point here, you can kind of maybe put this in your memory bank. You always, always, always read a line from left to right, right? Read a line from left to right, just like whenever you read a sentence in English, you read a line the same way. And that way you can tell if it's going uphill or downhill or if it's staying flat or whatever, right? Every year I usually watch the Brain Pop video, the Tim and Moby video about this, where they're at a skate park. And so I always like to put a little Tim and Moby stick figure here on the left-hand side, right? On the left-hand side. On the left-hand side. This doesn't have a left-hand side. We'll worry about this in a second. And so if you're at the left-hand side and you have to go uphill, anything that's increasing, going uphill, is going to have a positive slope. It's going to be a positive number. Anything that from left to right is going downhill, from here, left to right, you'd be sliding down this like a snow covered hill or something here. This is going to be a negative number. Anything that's completely flat, like walking across the stage in my room, or walking on a treadmill where you don't have the incline set, right? Just going straight across has a slope of 0, and then this is not going across at all. You would, my little stick figure here, Tim and Moby, you'd almost have to like bungee jump off of this thing. This is going to have undefined, I had to abbreviate here, undefined slope. The slope is not possible, and we'll show you why that is in a second. But the important thing to remember, when you look at a line, you have to go from left to right. You have to go from left to right. Otherwise, it's going to be backwards, right? Okay, let's actually do some of these. The two types of questions you'll get, notice, whoa, we've got a piece of paper here, not the actual whiteboards, right? Half of the questions today are going to be based off of graphs, actual graphs. Can you tell me the slope of this line? Okay, how do we do this? I'm going to go from left to right. I can put my little stick figure on there if I want, right? I'm going to go from left to right. Now, the book is actually being nice here on these first couple, and they've given you, or I've given you, the actual points that I want you to use. But to be honest, you could use any points. It just doesn't always work out that there's other points on there. Like this isn't like a point that I can really tell because it's like, you know, it's not like perfectly on one of the corners there. This is kind of like in the middle. And so you want to try to find points that are right on actual coordinates that you could recognize. Like here and here, I've got my 2 points. And let's go ahead and see what our slope is. Remember, what we're going to be looking to do here is we're going to be looking to find y, the change in the y, how much it's rising over how much it's running. You can write it like that, or you can write it like this, rise over run. Something like that, right? So how do I do this? I start at the point on the left, and I just figure out to get from this point to my second point, how many spaces will I have to rise up, right? If I'm going to rise up here, I'm going to draw 1, 2, 3, 4. I don't know if you can really tell there, but I actually drew little arrows. I'm going up 1, 2, 3, 4. I have to rise up 4. So right now my answer is going to be, I'm going to rise. You don't have to put the word rise in front of there, but I like to put it just to help me remember the order I need to go in. I'm going to rise up 4 boxes, right? 1, 2, 3, 4. And then I'm going to have to run over 1, 2, 3. I like to draw arrows, but you can just count these sometimes. 4, 5, 6, 7. Up 4, 1, 2, 3, 4, over 7. Let me double check that. 1, 2, 3, 4, 5, 6, 7. And there it is. So I had to go up 4, over 7, right? And so I'm going to run over 7. Rise 4, run 7. Can I reduce that fraction? No, I cannot. So my answer on this one is going to be the slope equals 4 over 7. And you just leave it like that. Don't try to make it a decimal. Don't try to do anything. If this happened to be an improper fraction, we would keep it improper. Like if for some reason you had like 7 over 3, you would not say 2 1/3 or whatever. Just keep it as 7 over 3. All right, let's do the next one. Same idea. Now this one, remember, we have to go from left to right. Left to right. This one's going downhill. If I put my little Tim and Moby stick figure here, they're going to be sliding down this hill. I know this is going to be negative. If this is not negative, I've screwed it up, right? To get from here to here, here's my 2 points. This time I'm not rising at all, am I? I'm actually falling. I'm going down 1, 2, 3. I'm actually falling, or I'm not really rising at all. I'm doing a run. Let me fix that. I said that wrong. I'm not rising. I'm actually falling. So to represent the fact that we went down 3, I'm going to put this negative, right? Since I wasn't really rising at all, I was falling, I'm going to put rise as -3, and then the run, how far did I have to go over? I'm going over 1, over 2, 2 to the right. You should always, always, always be going to the right whenever you do the run. If you're not going to the right, that means you've made a mistake and you did something wrong in the first step. So here it is. I was rising -3. That means I actually went down -3 or down 3 places, and then I went 2 to the right.
Nellie Benavides, call the office, please. Nellie Benavides, call the office.
Sorry about that. And so this means my answer is -3 over 2. M equals, that's an M equals, -3 over 2. Do not make that -1.5. Do not make it -1 1/2. I mean, technically that's not wrong, but no one ever writes slope like that. People always keep it as a fraction, even if it's improper. Okay, these down here I made a little bit tougher because I didn't put the actual points, the coordinates on there. And so if they don't give you the coordinates, you've got to use your own brain to find two places that would make good sense to put coordinates. Try to find places like here where it's right on the x-axis or the y-axis. Like here, I know the name of this point, right? 1, 1. This isn't really, that's kind of in the middle. That's kind of close. It needs to be perfect. Like right here, this is perfectly on the point, -4, 3. So if it's kind of like in the middle or not perfectly lining up right on one of those blue corners, just forget about it. Wait until you find one that's perfect. So here we go. I'm going to go from here to here. My stick figure is going to be going downhill again on this one. This is definitely going to be another one that has a negative slope. So I'm going to start here. I'm going to go down 1, down 2. And look, if I go down 2, I'm already at the level of this point. So down 2. So my rise is not actually a rise at all because I went down. So that's a clue that has to be negative. So I'm going down 2. And then I'm going, oh my goodness. I'm so sorry. Keep interrupting me. And then to the right, I'm going to the right, 3, 4, 5, right? 2 down, 5 to the right, 1, 2, 3, 4, 5. So we went down 2, over 5. Remember, see how that running action is always to the right? Down 2, over 5, and there is your answer, -2 over 5. I could rewrite it, but let's just say that. The slope is -2/5. And then for the last one, same idea. I need to find two places. This is not, that's kind of like down in the middle. This spot looks okay. This spot looks okay. And maybe even this spot right here looks fine. You could pick any of those. It doesn't really matter. You should get the same answer either way. Here, let me show you. I'll do it first with these 2 points, and then I'll do it with those 2 points. You could even do it with these 2 points. You should get the same thing no matter what, right? If I do it with just these first 2 points, look at what I would get. I'm going up from, remember you go left to right, so we're going uphill. I'm going up 3, 1, 2, 3, over 3 up, 1, 2, 3, 4, up 3 over 4. So I rose 3, I ran 4. So I think my answer is 3/4. I bet it's going to be the same thing. If I use this point and this point, it should be the same. Oh, it's actually not. 1. Well, that's just because I didn't draw it very well. This one's actually up 2 over 3. Up 2 over 3, which 2/3 is close to 3/4. Let me see if I did this point and this point. If I go up 1, 2, 3, 4, up 5, and then I go over 1, 2, 3, 4, 5, 6, 7. Holy cow. I got 3 different answers there, didn't I? I got 3/4, I got 2/3, I got 5 over 7. So the bad news is I didn't draw my line well enough because all of those are close. Like this is 75%, that's 66%, that's, I don't know, whatever this. They all are similar. The good news is all of these are close enough that if they had to ask you this question on like an assignment, they wouldn't give you all 3 of these choices. It would be very, very obvious that one of them would be right and one of them would be wrong. I'm going to pick 3/4 just because that's what I did first. But normally they will have the points laid out there on you, on the line for you. So I apologize that when I got different answers just because I use a really thick marker here or colored pencil and I'm not always the best at drawing the lines perfectly straight. It's different when you're drawing it freehand than when you're doing it on a computer or something. Okay, we're at 13 minutes. I need to hurry up and wrap this up. The last thing we're going to do today, what do we do with slope if they give it to you in a table, right? Or what do you do if you really want to, maybe these don't count by ones, maybe these are counting by like 50s or 20s or something, where it's a little bit tougher. If they don't give you points that are really easy to use, you can use the slope formula. Remember the slope formula is right here, y2 minus y1 over x2 minus x1. I'm afraid that yellow is not going to show up very well. y2 minus y1 over x2 minus x1. Okay, we'll do a few of these and then we will get out of here. This video may be a little bit longer than I wanted. So they give you a whole bunch of points here. Do I have to pick all of them? Nope. You just need to pick 2 points. Pick the ones that are the easiest. For a lot of people, you may just pick the first 2 points just because that is what's staring you in the face, right? And so maybe you say, I'm going to pick this one for point number 1 And I'm going to pick this one for point number 2. That's a little star. That's what that is. Point number 1 and point number 2, right? So you have chosen you've chosen 4, 20 with 7, 14. Those are your 2 points. And this one's number 1 and this one's number 2. And just like we did on the example a minute ago, this is always the x, this is always the y. I'm going to put 1s on this one because I called it point number 1. So this is going to be x1 and y1. My 1 will show up. This is point number 2. And so this is going to be the x from point number 2. This is going to be the y from point number 2. And then you just plug it into this formula right up here that I'm kind of have off camera. y2 minus y1 over x2 minus x1. So if I just kind of work this out, y2 minus y1 over x2 minus x1. Still got a little bit of the yellow on that marker. And so the y from point number 2 is right here, the 14. The minus y1, the y from point number 1. Here's point number 1. My y coordinate is 20. Oh, this is going to be negative, but that's okay. And then x2 minus x1. The x from point number 2 is 7. The x from point number 1 is 4. So x1 is the x coordinate from point number 1. And then you just work this out. 14 minus 20 is negative 6. 7 minus 4 is 3. Should I reduce that? Yes, you should. The slope of this is negative 2 over 1, which obviously you don't need the negative 2 over 1. You could just say negative 2. Okay, so that's how you'll do these whenever they give you a table instead of giving you a graph. Because the graph is nice whenever they give you one, but they don't usually give you a graph. And we should have had the same answer if we had picked a different point on there as well. So like maybe on this one, maybe negatives scare you, so you don't want to deal with negatives. Maybe you say on this one, this is going to be my point number, maybe these two, right? This is going to be point number 1, and this is going to be point number 2, just because it's easier to deal with positives than negatives. The good thing about it being up to you is you can pick the ones that you like the best. Now, I noticed the y coordinates are the same on these. That's going to be a little bit scary. This is going to be my number 1 point. This is going to be my number 2. Here's my x coordinate from number 1. Here's my y coordinate from number 1. This is point number 2, so both of these are going to have 2's on them. And so there we go. The formula says y2 minus y1. y2 minus y1. The y from point number 2 is right here. The coordinate from point number 1 is right here. Uh-oh. Then on the bottom, the x from number 2's x is right here, 5, minus x1. The x from number 1 is 3. And look what you get. You get 2 minus 2 on the top, which is 0. 0 over 2. That is the same thing as 0. This line is completely flat, right? Completely flat line. So there's number 2. Now, if you actually hated to do it this way, and you were throwing a fit that you had to do it this way, could you, in theory, take out a piece of graph paper and graph all of these and do them just like we did the ones a second ago? Yeah, you could, but I don't know if I would do that. That's not very fun. Okay, here's the next one. These are all negative 3s. My handwriting wasn't very good. Maybe you pick these two because these don't have any, no, they don't have, well, they have negatives, but they don't have negatives in the second number. And so you're going to call this one point number 1. You're going to call this one point number 2. And some of you could even say this is your x from number 1. This is your y from number 1. Here's your x coordinate. That's an x. It doesn't look like it from number 2. Here's your y coordinate from number 2. Like if you really wanted to write it like that, you could. So here's your formula again, y2 minus y1 over x2 minus x1. The y from number 2 is right here, the number 2 point, y coordinate, which is 9. Minus y1, my number 1's y coordinate is 6. So I definitely have 3 on the top, 9 minus 6. Now we're going to do the x's. The x number 2 is right here. That's a negative 3, even though it doesn't look very good. And then minus the x from number 1 is also negative 3. Negative 3 minus negative 3. The minus and negative, right? 2 negatives make a positive. Negative 3 plus 3 is 0. Uh-oh. This is not possible. 3 divided by 0. You cannot have 0 in the denominator. This is no solution. There is no answer to this. This is why we had the one earlier that was undefined. Undefined slope. This is a vertical line. If I graph this line, it would be straight up and down. Anytime you get dividing by 0 on the bottom, you know you have a vertical line, and that has undefined slope. Don't put no solution on this one. Don't even put this. Just write it as undefined slope. Okay, last one, and then I promise I'm done. I'm so sorry this is going to be like 20 minutes instead of 15. If they write the table sideways, don't let that throw you off, right? You can still do it. Maybe you pick these. Maybe you pick this point as number 1. Oh, this marker is just completely just erasing the other line. And maybe you pick, let me use this blue in here. Maybe you pick these 2 points, right? 210 and then 415. Those are going to be your 2 points. And so I've chosen the first one, which was 2, 10. They just wrote it differently. The second one, I chose this one, which was 415. And then you can label them as number 1 and number 2. I always like to pick this one as number 1 and this one as number 2, but honestly, you'll get the same thing if you do it the other way. Here's the x coordinate from number 1. Here's the y coordinate from number 1. Remember, it always goes in alphabetical order. X coordinate from number 2, y coordinate from number 2. And so then we can just plug it into the formula. The final formula, y2 minus y1, x2 minus x1. Here we go, the y from number 2. Number 2 is right here. The y coordinate was 15. Minus the y coordinate from number 1. Number 1's right here. The y coordinate is 10. So we definitely have 5 on the top of our fraction. And then on the bottom, the x from number 2. Here's number 2. The x is right here, 4. And then x1, here's my point number 1. The x coordinate is 2. So if we have 4 minus 2, which is obviously 2, 5 over 2, I'm going to keep it as that. I don't want to call it 2.5. I don't want to say 2.5. I know those are technically right, but no one really writes slope that way. So, okay, I'm so sorry this took 20 minutes. I hope it makes sense. If you needed to learn a little bit about slope from a table and slope from a line, hopefully these 2 aspects helped you out. I'm going to put some questions up on the Big Ideas Math site. Give them a try, but feel free to email me if you have any questions. All right, see you all.